Let's go over some basics of database design. So we look at these relationships in an ER diagram. Now, there are many different ways of drawing an ER diagram. If you go online or read books, you'll see different notation, different ways of drawing the same relationship. Some use like a crow's foot for many, some use the numbers, some use two numbers, some use a diamond, some use dashed lines. So it's a bit confusing what you're supposed to draw. So let's simplify it. Let's say a simple line with a crow's foot, or a 1 and an M is a one to many, and a complex way of that is putting a diamond in the middle to signify what relationship it is. So start off with something simple, and then if you want to add more detail later, make it more complex. So here's a ER diagram where every entity has a one-to-many relationship with the other entities that it's related to. So we have a customer has a one-to-many relationship with an order, item goes to order, one-to-many, order, we have order line, and item and supplier. So one supplier can supply many items. So that's an example of an ER diagram just using one-to-many relationships. So when you make an ER diagram, try to keep it simple. Think about the entities first, what relationship, and the cardinality. That's the important part in the design. So check to make sure you've got the correct cardinality, 0 to many or 1 to many, for example. Now once your design is correct and you're happy with it, then you can start adding detail about what you want to call the relationships, putting them in a diamond and adding the attributes, for example. Let's think about some of the design considerations. So here we've got two types of relationship. We've got customer item, which is here a many-to-many relationship, and an item product details, which is a one-to-one relationship. So maybe we need to look at these in more detail. So a many-to-many relationship is correct notation, but it's not correct design. We need to change that for a database. So we can change it by creating a junction table. So here, many customers make many or order many items, so we can create an order entity, and there are many relationship changes from many to many to a customer to order one to many relationship, and item to order one to many relationship, which is good. This is what we want. So a many to many relationship can be solved by a junction table. Now if we think of the real world, we might have a look at a receipt, and an order might have more than one item on there. So here's an example of a receipt. Now here's, if you like, an order. Now the top and the bottom of the receipt show a lot of order details, but in the middle we have different lines that show the items, the amount of items, the cost of the item, and the total the cost of that line. So we could create another table called order line, and then put those lines inside that table, and then relate that order line to the order number from the order table or entity. So in our design we would have customer item, we have a junction table order, but now we also have order line. We can add more detail if we like. For example, here we could add the supplier of the item. Now what about product details? So we can have quite a lot of product details, so we could put that in a table, but each product is a one-to-one relationship with the product in the item table. It's the same thing. So do we want a one-to-one relationship? Well, maybe not. In this case we could put all of the product details, if you like, the whole text in one cell in the table of item. So the entity item could have the attribute which is the product details. So we wouldn't need to have another table, for example. Now let's have a look at some different designs which look the same in the ER diagram, but it depends on the actual design, the database itself. So what do I mean? Well, here we've got customer booking. We've got a one-to-many relationship, and there's somewhere along the line there's a payment. So do we have a payment table? And if we do, where does it go and what's it related to? This seems straightforward, but it's not the same for different cases. So let's have a look at some examples. So here we've got a payment table. So we've got customer and booking, and we've got on the side you can see many customers make many bookings. Is the payment a separate table? If it is it related to customer, booking, neither, or both? So example here, we book a flight. Well, when you book a flight, you make the payment straight away. So do you really need to have another table for the payment? You could do, but you could actually put it as part of the booking table. So the payment table, you don't really need it if it's part of the booking itself, such as when you book a flight, when the booking and the payment are in the same event. Example 2, booking cinema tickets. Well, that could be the same, but you might actually pay at a different time. So you could actually update the booking table once you collect the tickets. So you could have a field with like reserve and deposit and paid in full and cancelled, etc. So that is part of the booking table, a bit different. And what about if you collect the tickets, you want to make a payment table? You can do that. So it's the same example, but here we use the payment table. And this is connected to the booking table. Example 3, book a hotel room. Now you don't pay when you book, but you can pay when you arrive or you leave. You might even pay a deposit. So essentially there could be multiple payments. So that would generally suggest you make a payments table, and that would be linked to the booking table, booking entity. Now here's an example. You book lessons. Now the customer pays every month in advance. If you attend or don't attend, it doesn't matter. And it depends if you need to keep attendance or not, but this design doesn't matter on attendance. So the customer makes a payment every month. So the payment table is actually connected to the customer table. Example 5, very similar, books lessons but pays for a block of 8 or 10 hours in advance. Attend when the customer attends when they want. Now in real life we might have a card where the customer attends and then the card is marked to say they've attended, and once they've got the 8 marks or 10 marks, then they have to repay. So we can think of items that we use in real life to help us with our design. Again, the entity or the table payment is connected to the customer. So we've seen this payment table as part of the booking table, connected to the booking table, and related to the customer table. So which one's correct? Well, they're all correct for their own design. The ER diagram describes the design. The design doesn't change to the ER diagram. Now there are anomalies, things that we are aware of that are not normal, and we have to deal with these kind of separately. So we can use test data to see if our design works. So that's more the physical design rather than the logical design. So briefly, let's look at an ER diagram. Well, as we said before, there's quite a lot of different ways of drawing an ER diagram. So it's up to you how you want to use whichever symbols you like. But be aware when you go online there's different ways. It can be a bit confusing. Different styles. So for example, we can have attributes, so simple attribute such as 1001, composite, so it has an attribute but made of different parts. So a name could be first name and surname, and address we would have separate attributes for perhaps line 1, line 2, postcode, maybe area and country. Derived attribute, we wouldn't have age in a database, we would have date of birth, and then we would calculate the age inside the database. So that type of attribute can be signaled with this dotted oval. So here's an example of a composite attribute. We've got the cost, and that's made of parts and work. So we can think of an ER diagram to help us in design, to keep it simple, to make sure we've got the entity, relationship and cardinality correct, and then once we're happy with our design, to show the detail, we can make it more complex by adding details of the relationship and also the attributes and type of attributes. We can also make the ER diagram enhanced. So this is incorporating a bit of OO design, object orientated design. So here we have a superclass called employee, and we have mechanic and salesman. So a mechanic is a type of employee. An employee is the superclass, or a salesman, salesperson, is an employee. So salesperson, salesman, mechanic are subclasses. A generalization. So a car and a truck are types of vehicle. We can use this notation to show a generalization. Now a bike could be a motorbike or a bicycle. So these are specializations. So we can use similar notation. You may see the circle, which is a type of is-a relationship. So a motorbike is a bike, a bicycle is a bike. Now inside the circle we can have letters. D stands for disjoint. The disjoint rule means that the bike has to be either a motorbike or a bicycle, but not at the same time. So it can be either one. Now if you see the double lines, it means it must be one of the options. So here we've got staff or paid or unpaid. They can't be anything else, just either paid or unpaid, one or the other. Overlap, so we have a car and a truck. Now a vehicle could essentially be a car and a truck, but in a database it has to be one or the other. So in a design we put something that's a car in cars, something that's a truck in truck. If we're not sure, we have to decide which one it's going to go in. Here we've got union. We've got a vehicle is owned by either a person, a company or a bank. So it's owned by one but not all. So we can see the symbol U inside the circle.